Science and Biology. Today, I am glad to introduce our resource person for the session, Dr. Tapu Brata Lahari sir. Dr. Tapu Brata Lahari sir, working as Professor and Dean in the Department of Applied Mathematics. Sir has completed PhD in the area of biological image processing and simulation. Dr. Tapobrata Lahari sir is the member Senate and Board of Governors and also he is the member in Indian Institute of Information Technology. Sir has served as a research advisor at Nan Academy of Science, Singapore, and also he is an expert at quality control of India. Dr. Tapobrata Lahari sir has received certificate of membership from MHRD's Innovation Cell in appreciation for contribution in the institution's Innovation Council established under MHRD's Innovation Cell at IIT Allahabad. Sir's field of research interest are on the applications of data science to study pathophysiological manifestation caused by biomolecular and other health factors. He has brought 6 sponsored projects so far, out of which 3 are Indo-Russian, and also published 30 peer-reviewed journal papers. Sir has served as a reviewer for SCI and IEEE transaction journals and also served as key contributor in starting continuous assessment system framing of NEP inspired programs and establishing patent and incubation cell at IIT Allahabad. Already 8 candidates have already completed PhD under the guidance of Tapobrata Lahari sir and 4 of them are pursuing. Sir holds postdoctoral positions in the various universities. I wholeheartedly welcome you to this session, sir. Over to you.
Thank you so much for giving such a spectacular introduction. Well, let me share my slide first. Is it visible to all of you? My slide?
Yes, sir, it's visible, sir.
Okay.
Sushma madam, please turn off your camera and mute yourself.
So very good morning to all of you. Today we are going to discuss, as I have already sent, the title is reflecting my intention today. This is nothing but to actually discuss the fundamental aspects of not the subjects, but the association of two subjects like computer science and engineering and biology. And that will be discussed with the help of examples, obviously. And first of all, I would like to point out that the logical basis and a method of reasoning is actually the primary basis, the main standpoint for all of us to understand any subjects, be it of science or engineering. So we cannot avoid this logical basis. So obviously, whenever we are thinking of any logic, then obviously logic must have to have some sort of association with the data. It may be of numerical form, it may be of any other form. This data is of prime importance to us. And over there, when we are talking about data, then obviously the first question will arise that why data? What's the special thing of about data to discuss about? So the data, we should not think data without its association with some of our object of interest or system of interest. So data is actually related to our object of interest or system of interest. There actually lies the importance of data. So obviously, without the association of the data with a kind of system of our interest, it will have no meaning. So we normally forget about this system of interest while we are thinking of data and the computational part, and to learn many computational tools. Then we forget about the association of this data with system. So today, what I believe that
ಸರ್
yes
ಒಂದು
hello
5 ನಿಮಿಷ ಬರಕ್ಕಾಗುತ್ತೆ. ಒಂದು ಲ್ಯಾಟರಲ್ ಎಂಟ್ರಿ ಬಗ್ಗೆ ಒಂಚೂರು ಡಿಸ್ಕಸ್ ಮಾಡ್ಬೇಕಾಯ್ತು.
pardon, I cannot hear you properly.
ಈಗ ಲ್ಯಾಟರಲ್ ಎಂಟ್ರಿ ತಗೊಳಕ್ಕೆ ಪ್ರಾವಿಷನ್ ಕೊಟ್ಟಿರೋ ಯೂನಿವರ್ಸಿಟಿ ಈಗ ಥರ್ಡ್ ಸೆಮಿಸ್ಟರ್ಗೆ 107 ಸೀಟ್ ಇದೆಯಲ್ಲ, ಈಗ ಬಂದಿರೋ ಸ್ಟೂಡೆಂಟ್ಸ್ ಎಲ್ಲ ಥರ್ಡ್ ಸೆಮಿಸ್ಟರ್ಗೆ ಎಂಟ್ರಿ ಮಾಡಿಸ್ಬಿಡೋಣ ಅಂತ ಇವರು ಚೇರ್ಮನ್ ಕೇಳ್ತಾ ಇದಾರೆ. ಅದಕ್ಕೆ ಈಗ ಅವ್ರು ಏನ್ ಹೇಳ್ತಾ ಇದಾರೆ, ಫ್ಯಾಕಲ್ಟೀಸ್ ರೆಡಿ ಇದಾರ, IA ಕೊಡ್ಬೇಕು ಪ್ಲಸ್ ಎಕ್ಸಾಮ್ ತಗೋಬೇಕು ಅವ್ರು ಬಂದ ಲ್ಯಾಟರಲ್ ಎಂಟ್ರಿ ಸ್ಟೂಡೆಂಟ್ಸ್.
Swami sir,
Yes,
please mute your mic. Sorry for the disturbance, sir.
okay, no problem. So what I mean to say is that this association of the data with the systems of interest, whatever is there for us. So this system is prime importance to us. So my point is actually we forget this prime importance, that is the systems of importance. We forget about that, and while we deal with many means application of many computational tools, then obviously we think that yes, we have to learn the computational tools, many computational tools, like whatever is there of our importance, like machine learning, like optimization, like this systems modeling and simulation, then kind of mathematical tools, means differential, partial differential calculus, the solution of that. So we forget about the system. So today I want to focus on that. I believe that without thinking of the system of interest, we should not enter into the arena of this computational sort of aspects or application of any computational tools. So that I will actually try my best to discuss with the help of some examples. And next slide, actually, I'm going to discuss about all these things. So let's discuss about the fundamental aspects of reasoning, the method of reasonings. So we get that there are mainly the three types of method of reasonings, mode of reasonings. One is actually the deductive mode of reasoning. Deductive mode of reasoning it actually relies on a kind of generalization of fact, and it describes the general actually aspect of the fact, and that we can actually refer as our first premise. The example is any solar planet move along an elliptical path. Then if Venus is a solar planet, there is the second premise. Therefore, Venus move along an elliptical path. That becomes the conclusion. So apparently it appears to be very sound, very good, but flaws are there. Obviously flaws are there. So in the next slide, we can find out that for this deductive mode of reasoning, the not so good example is all cats have 4 legs. Then Don is a cat. You know very well that all cats have 4 legs. This first premise may not be so correct, because a cat may lose its leg due to many reasons. So that may not be so sound. And then if Dawn is a cat, therefore Dawn has 4 legs, this conclusion may not be right sometimes. The very bad example is actually to have the wrong abstraction of the whole premise. The bad example, you can see that all policemen are instruments of law. The piano is an instrument, therefore all policemen are pianos. So this is a very wrong abstraction of the first premise. So we should be very careful about the reasoning, mode of reasoning and method of reasoning, and our starting point from where we have actually initiated the whole set of reasoning. So those things are very important. Another mode of reasoning is actually inductive reasoning. We utilize all these types of reasoning in case of our computer science and engineering while we actually deal with the computational methods. We apply this mode of reasonings in case of biology while we are actually trying to interpret some biological phenomena or biological system. Then comes this inductive mode of reasoning. Over there, we find that, let us go by the example, 90% of graduates from Excelsior Preparatory School go on to university. That is the first premise. And then second is Bob is a graduate. It's a fact. Bob is a graduate from Excelsior Preparatory School. That is the second premise. Second premise based on the fact. Therefore, Bob will go on to university. That is the prediction. So there is no big claim about the decision that Bob will go on to university. There is no such big claim, but it is a prediction. So it's quite well defined. And so the prediction, when it is prediction, then obviously we can accept it in this manner only. Next mode of reasoning, I'm just reminding you because see, when we go for viewing one particular movie, suppose we want to we see these movies and maybe a thriller movie or a kind of detective types of movies. So then we actually have a lot of enjoyment over there. We enjoy it because we associate ourselves with the detective, the cop or the sleuth, and then actually we actually relish the kind of reasoning method of reasoning. We also do that along with this detective. We apply our method of reasoning, and maybe just before the detective actually comes to the conclusion, we could find out the conclusion. While we enjoy that, we actually normally don't bother about the way formal way of the reasoning. So the formal way of reasonings, what I am actually describing over here, that these 3 mode of reasoning, one is deductive, I have already described, one is inductive, and another one is right now I am describing. So you will find most of the method of reasoning, whatever you apply in day-to-day activities or in case of your research for your science and engineering problems, actually rooted from actually this abductive mode of reasoning or deductive mode of reasoning or inductive. So abductive mode of reasoning, what is actually being applied everywhere, and we can remember Sherlock Holmes' method of reasoning. That was mostly the abductive mode of reasoning. Here we find that the instead of premises, we are actually dealing with facts. The example is actually going like this. The old person is a confirmed COVID-19 patient. That is the fact 1. The person also has a confirmed report of entamoeba histolytica infection. That is the fact 2. And fact 3 is very, very important. Even in absence of any treatment, while the person is actually suffering with this COVID-19 and there is no treatment, the patient recovers within 3 days. That is the fact 3. So we find that these are the facts, and then we are actually trying to explain these facts on the basis of facts on the basis of the information we got out of these facts. So the explanation is like this: therefore, progress of COVID-19 infection is prevented by entamoeba histolytica infection. So we may have some counter kind of reasoning for that. But means first and foremost means explanation may be like this, and already we know that for any such explanation to be true, we must have to go by the means necessary and sufficient mode of reasoning. So these are the necessary mode of reasoning. So abductive reasoning are actually giving you the necessary mode of reasoning, and sufficient mode of reasoning, if we actually think of the sufficient the reasoning that will be sufficient for us. So for that we have to have a list of such abductive reasoning, quite a heavy list of abductive reasoning. If all are actually converging towards the same explanation, then obviously we can actually think about this, that this may be the decision for us. So just imagine the problem of the judge sitting in the court. Over there also, for any sort of crime, when it is a criminal case, the prosecution, when the prosecution actually deals with this matter, he submits the facts and the explanations. And judge has to actually decide on the basis of these facts whether he should accept the explanation given by this prosecution or not. So this is the mode of reasoning that is the central, and that is the mother of means our analysis, data analysis. Data is not, as I have already told you, that it is not only a numerical mode of data. It may be any mode of data. It may be a kind of language also. So over there, this mode of reasoning is more important to have a kind of convergence of the people associated with computer science and engineering and the people associated with this biological science. So next, let me start with one example. Over there, it is a very simple example. I have actually worked on this particular topic much earlier. The topic was very much interesting. The system of my interest was RBC vesicle, and over there, I should have also describe what is system, and system actually leads to a systems engineering. So obviously, what I am discussing is basically the very simple sort of explanation of systems engineering. Systems engineering, we all know that it deals with understanding of a system, analysis of a system, and system is of prime importance for any sort of analysis of data, as I have already argued. So over there, the basic and fundamental aspects of systems engineering is actually, I will go through that afterwards. So over here, my system of interest was RBC vesicle. RBC, you all know that red blood cell or red blood corpuscle, this vesicle, and it's a kind of cell membrane. Basically, the cell membrane, the rigidity or integrity of this cell membrane, it has to be maintained. Without means having this particular integrity of this cell membrane or rigidity of cell membrane, means RBC has a particular shape, we all know, and the RBC will lose its shape if it's something like that. It has lost its shape. Then obviously it will be a great problem for all of us. Means it may lead to the disease, many diseases, RBC shape oriented disease like thalassemia, like sickle cell anemia. So all these disease, the root cause is actually the problem of RBC, the cell membrane, the loss of the kind of integrity or rigidity of the cell membrane. And who actually maintains this particular rigidity of this cell membrane? Then actually the answer is actually a particular protein. The protein is actually that has been identified, that a particular protein is there. Its name is spectrin. So that protein is actually gives this particular maintains this rigidity or integrity of this cell membrane. So obviously, what I have done at that moment, that was a very primitive phase of this digital image processing, then kind of all other data processing tools. So that was a very primitive phase over there. But what I want to point out that the interesting association of the data, and without bothering about system, if we just apply some sort of computational tool, it may not work. Why? I am going to describe. So the four major branches of system engineering, I will cover all these things in this discussion through this example. So one is system study. So obviously we need to study. Data processing is actually context dependent. It is not only image parsing. Means in case of image parsing, from quite some time we used to refer this particular sentence that image parsing is context dependent. But I think it is applicable for any other computational tool also. Means this system, this data processing depends on the particular system of interest for which you are going to process this data. So first we have to study the system of our interest, system architecture, system dynamics. With time, how the system is evolving, systems analysis. So the means system variables. In one word, we have to think about system variables. System is a thing which may not be actually the whole part of the system. Maybe the particular part of the system, very minute part of the system, is actually describing the actually trying to fulfilling our objective. So we should be bothered about this particular part of this system instead of the whole system. A very good example is actually the human intelligence. If we think that this human intelligence, so we focus on the whole human, then it may be wrong from our part, because at that moment the suppose I'm just giving one example. I'm joking away, obviously, while I'm giving these examples. Maybe the human height. You may think that the human height is actually very much dependent on actually this intelligence. Intelligence is depending on this human height, and then there is an interrelationship. So you just go on reducing the height, and the intelligence will gradually increase. So if you think like this, it may be wrong, because at particular when we were actually reducing this height at a particular height, it may be the case that that is the optimum height, the means intelligence is maximum, and if you further reduce this height, then again the intelligence may reduce. Then we may focus on a number of hair on our head. Means I mean to say that we can think that the person who is bald is actually more intelligent than the person who is having a lot of hair. So I am joking, but we can understand very well that these things are not actually very important to actually explain the human intelligence. These are not actually important. So the part of the system, part of the whole human, it may be the kind of indirect way of actually judging the intelligence. The human means functional aspect, response against some sort of queries. I'm talking about intelligent quotient, IQ. So IQ may be a very good means kind of representative parameter for actually defining the intelligence, human intelligence. So that doesn't mean that whole human has to be studied. A part of the human means, or maybe its functional aspect may be studied. So we have to find out what are those very important aspects that is actually fulfilling our objective to define the intelligence over here. So it may be some special parameters. We normally refer them as system variable, who are actually important for our study. So and we can have some sort of statistical analysis, and we can have some sort of interrelationship between these variables. We can decide on that. So all these things may be regarded as very important to us. So the system study is very, very important. I will actually, when I will describe the thing with example, then everything will be clear. Systems modeling and simulation and validation. So systems modeling means our system, how it is actually working, how it is functioning. A particular functional aspect is actually is of our interest for this system. So we can try to model it. and while we will model, then obviously again the system variable which will be very important to us, and their interrelationship, which in coordination actually giving rise to some system function, will be of our importance. And then comes the systems optimization. So obviously we have to find out when we have decided on the system variables, obviously we have to think about the best values of these system variables. Best may not correspond to the maximum value of these system variables. Obviously, best will correspond to maximum or minimum of something. If it is to minimize the error, then it will be. If it is regarding error, then we have to minimize it. If it is regarding the performance of the system to accomplish something, so it may be the maximization task. So then obviously we have to think about the system variables, the base values of the system variables that actually leads to the optimization task. So first we have to think about the interrelationship of the variables that is actually giving us the idea of simulation. But then within these variables, we have to again work on that. We have to find out the best values of these variables, and that leads to the optimization process. And then obviously decision making about system and system classification through application of machine learning. So once we can actually somehow model the system, then obviously that before modeling or maybe after modeling, depending on our actually particular objective, we may have to actually think about system classification, means different outcome, and that is giving a different macroscopic view of the system. The microscopic details and microscopic functioning details may give rise to some macroscopic sort of formation of the system. And then once we understand that these are the difference among the macroscopic formation of the system, macroscopically we can actually somehow understand what is the difference, then obviously we can try to classify them. Like we all know that there is face recognition problem. So face recognition problem is also very important. And over there, we normally, especially we quite often give the example of the criminal set of criminal database, where there are a set of face images. And obviously our task will be to find out the match with this particular face images that is actually listed over there, that is stored over there. And if there is a good match, then obviously we can identify a particular person as a criminal. So this is a very good example. We all know that there are a lot of sort of work that has already been done for the past sort of age. It is actually happening like this. So these are actually giving us the idea of the systems engineering. Right now, again, let me give a very simple example of systems engineering. And for this purpose, I am actually presenting some figures before you. This figure has been made by the materials, the components that is actually giving rise to the formation of the RBC cell, means cholesterol, glyceraldehyde, all these materials, and dimethyl phosphatidyl choline. So all these materials which are found within the cell membrane of RBC, with the help of this cell, these materials, and actually creating an environment that is similar to the environment within which this RBC cell actually lies. So we refer it as a solution, buffer solution. So we have kept these materials within this buffer solution, and readily we found that there is a formation of this type of aggregates or clusters or aggregates. We can clearly visualize the whole thing. So these clusters or aggregates is giving us some idea about what is happening over here, a very rough sort of idea, because the first figure, whatever we are actually seeing over here, the first figure is actually the figure A. is for these RBC cell membrane materials and the aggregate that has been formed with these materials in absence of a particular protein. I have already told you that this protein is pectin. So this is in absence. And figure B, C, D, these are made with the presence of this particular protein. So this pectin in different amount with gradually increasing amount. So this protein spectrum, its presence and absence is actually creating a difference in this type of formation. We can clearly understand that. And the beauty is that while we clearly understand that, but then obviously the problem we are facing right now, how to actually characterize this type of difference. Difference is clearly visible, clearly understandable to us, but how to characterize? So we can actually go back to a kind of scenario where we regularly encounter some scenery. Scenery means it may be a scenery of cloud, or it may be a scenery of kind of tree, and forget about kind of color description of all these scenes. It may be a kind of means at the end of the day, all are actually all appears as kind of black and white sort of formation or gray formation. So over there, we can understand that this tree and cloud both are actually rough objects. They are actually made by some sort of assembly of some sort of subunits. Clouds rough, tree is also rough, but there may be some typical difference, and that is also a robust difference. Some robust characteristics are there. For that very reason, we find that human can readily understand that this is cloud and this is a kind of tree. Even in a gray image, we can readily understand. So we should try to find out this robust signature out of these two rough objects. And over there, we interestingly found that fractal dimensional analysis is a very prominently famous sort of tool these days, technique and mathematical technique, which can help us in this regard. And in case of fractal dimensional analysis, normally we study the scale dependence of our object of interest. So while it is a formation, maybe a aggregate, so if we think that these are nothing but a kind of point objects, so points are getting assembled, so obviously within a two-dimensional area, it appears to be two-dimensional, but it is obviously three-dimensional, and these are microscopic images. So obviously, an ordinary microscopic images, phase contrast, and we have put our this substance solution in a hemocytometer, which is a lamellar space, which gives a lamellar space, and over there we found that this type of formations are there. So this lamellar space in real life scenario, we can consider it as a kind of two-dimensional sort of space over where these point objects are actually getting assembled and forming this type of signatures, clusters, aggregates. So obviously, we can understand that the dimension of this type of objects, these are not exactly points because it is deviated from a point sort of thing. It is actually going towards a two-dimensional object, going to be a two-dimensional object. So it is in between kind of point object and two-dimensional object. So obviously its dimension should be in between 0 to 2. So if we think that these are the point objects, if we think that these are the linear objects, then obviously, and curvilinear objects, then obviously its dimension should be accordingly 1 to 2. So the dimension should be a fractional dimension, and we refer it as fractal dimension. So this fractal dimension analysis can be done for this type of object, and all these things we are actually at that moment, that challenge has been thrown to me, and readily these type of things came into my mind, because I was actually dealing with fractal dimensional analysis. I was dealing with image processing. So all these things came to my mind, that for this particular formations, aggregate formations within the image, we must have to actually focus our mind first, that what kind of this system is there, what kind of object it is. So, and then we should think about its processing. So obviously I thought that we should try our best on the basis of fractal dimensional parameters. So let us actually extract some fractal dimensional features from it, and let us see whether we can describe this particular happening in terms of these fractal dimensional features. So that's the means what should I say, the beauty of this context dependence, and to actually honor this context dependence by us. So we should honor that it is having a context. Without honoring that, if we just blindly give these images, even if we give it to some sort of, suppose, deep learning sort of framework, artificial neural network framework, without being bothered about means what is the actual system over there, then obviously it may have the ability to actually discriminate between these cases without spectrin and another addition of with addition of spectrin, means presence of spectrin and absence of spectrin, and the formation of these aggregates. Deep learning method can somehow do that, the discrimination, without having any idea that what more information we can extract out of that. So that is the problem with this. So when only discrimination is our target, then obviously we can apply those tools. But if we have to explore more, we need to understand the underlying reaction mechanism for this type of activities. Then obviously we should have the kind of some sort of mechanism to understand all these things. So over there, our initial study of our system, that is the system, the first step of the system engineering aspect, is should be done, and then obviously we can move forward. And another thing within this image, if I just show you this image in a zoomed version, then you see the both of these aggregates are of same nature. If you just forget about the first image, that is actually giving you the quite well separated aggregates, and in other images it is actually the aggregates that is spanning through the whole image area. So it is a spanned sort of aggregates, and it is well separated aggregates. So these are the difference. Then the underlying means intrinsic characteristics of this type of aggregates, if we just follow that, then obviously we find that these are very similar to each other, with the difference that this aggregate is well separated from each other, and these aggregates are spanned, it is covering the entire area of the image slide, so or image viewing area. So then obviously we may be interested to know whether there is any difference in the intrinsic properties of this type of aggregates. So in case of intrinsic properties, we know that aggregates are formed whenever there is aggregate. Aggregate means assemblies. So assembly is formed by some individual units. We can refer it as subunits. So subunits gets assembled. When it gets assembled, think about some balls, suppose tennis balls, and if you just put these tennis balls, 100 such tennis balls within a kind of container, it will form a kind of assembly. And over there, the main interesting feature is actually the internal space created by this type of arrangement. So internal space, I am talking about internal space means porous area, that is constituting the porosity of this type of assembly. So this type of assembly, we know that it is a three-dimensional formation, and for three-dimensional formation of such assembly or aggregates, the term like porosity was already there. Then I thought that why not I can think about a two-dimensional porosity, because whatever formation we are having, just in the context of real life scenario, we can consider it as a two-dimensional formation. So we can actually think about a two-dimensional porosity. So over there, I have studied this two-dimensional porosity also, and obviously I had to do some sort of digital image processing, and all the algorithms were quite novel, because I have actually, what I did was actually I first segment out these images, and then after segmenting out these images, that is the black and white formation. Means white means the object part, and black means this background part. And over there, I have a kind of sliding of this type of images, so artificial sliding, towards various direction, and I have a union of these images. That union, from this union, I can have the idea of the area covered by these aggregates, total area, including the porous area. And if I just do the intersection, that will give us the kind of, without having any interaction, obviously this union will give us the total area covered by these aggregates. And without doing this type of unions, without taking this type of unions of these images, we will have the raw image, obviously binary raw image. That image is giving us the area of the aggregates without this porous area. So if we just subtract the union image from the raw image, raw image from the union image, then obviously the difference image is giving us the area, porous area. And with the help of this, we can compute the fractional porous area also. So that gives us the porosity value. So let us see what happens with this type of features, which are actually very much relevant in the context of such aggregates. So we have designed these two parameters, 2D porosity and then fractal dimension. One is a known one is a novel one, and we got a formation like this. Means with the amount of spectrin starting from the 0 and then a gradual increase of this amount of spectrin in microgram per ml. What is happening with in case of this porosity? We can actually see that there is a gradual increase of these values of porosity. Obviously, it appears to be a bit asymptomatic, and then there is a gradual increase of this fractal dimension also, and this is obviously a bit parabolic. Appears to be converging or actually having some sort of plateau, actually moving towards saturation. But somehow, maybe we are moving towards saturation, but we can actually somehow, these are very well-defined sort of plot and can be modeled through some mathematical equation also. The main target was not like this. Main target was to actually classify the outcome. So outcome means these two events. One is in absence of spectrin, another is in presence of spectrin. So we found in our utter happiness that we refer it as DP diagram. D means fractal dimension and P means porosity. We found that all the cases in presence of spectrin and in the absence of spectrin, they are actually forming distinctly different spaces within the DP database, within the feature space that is constructed by D and P. Simple D and P is actually giving us this kind of discrimination. Just imagine. So it may not be so much of means kind of analysis and computation. It's just this. This DP diagram is giving us this type of discrimination, and whoever among us we do machine learning, so we know that this type of means totally separated formation of classes is actually very much actually welcome sort of thing for us to discriminate two different classes on the basis of their positions within the data space. It is totally fully non-overlapping. So any rule-based simple classifier will work on it. So now we understand that beauty of context dependence and to actually honor the context of the system while we are trying to do some sort of data processing. Now, after actually having this type of classification of the system, we were further interested about what is actually giving rise to this type of formation. And for this, obviously, there comes the role of systems modeling and simulation, actually to actually recreate the crime scenario. Recreate the crime scenario means I'm jokingly saying all these things. Crime means means this system performance, system variables in coordination, how they are actually giving rise to this type of formations. These two different formations. So, and why we are interested to simulate these formations, that is only to unearth or to reveal the role of spectrin, this protein, from where we have started our this type of business. So we have actually, we were very much interested to actually use the role of spectrin and how this characterization is going to help us. So again, what I have already told you, that we need to recreate the crime scene. So the reaction mechanism that is leading towards formation of this type of happenings. So obviously, the reaction mechanism may be defined as a very simple sort of in silico sort of process, which gives rise to this. And over there, a very important thing is to consider the system scale. I'm going back to these figures again. See, in this figure, if we think that we have to actually deal with the formation of the vesicles, means RBC vesicles, cells, and then how the cells are actually getting assembled. So it will be it may be a two-phase problem. So instead of doing that, if we just look at this problem in a kind of reductionist view, that first there is a formation of this RBC cells or vesicles, and then obviously we are going to get the kind of assembly of these vesicles, maybe in presence of spectrin and absence of spectrin. So if we start with the vesicles which have already been formed, so then obviously that is actually giving us the system scale. System scale is our starting point will be the vesicles. And again, if I go back to the previous figure, then if we just focus on the well separated aggregates, then we find that these aggregates are well separated, and how it is formed, then obviously we can think of a mechanism where the first we are actually getting the appearance of some seeds in terms of, means this type of simulation we refer the initial points as seeds. So these initial points or pixels, each pixel we can think of as our this particular vesicle, and then how these vesicles are actually growing. From one vesicle there may be formation of other vesicles. It happens biologically, it happens, we know it. So from one it may be a formation of two vesicles, then three vesicles. So we can think of a kind of models which actually can help us in this regard. So we found that there is a model like Mole's labyrinth model, where it considers random appearance of the seed points within the means this type of system space. So if the seed points appears in random, then obviously then the question will be how from these seed points the formation of this type of aggregates are happening. So next is actually to think about the formation of this assembly in a manner which is again somehow we can find out the instance of this type of model somewhere, mathematical model. So we found that another simulation model is there which gives us the idea of such formation, and it is called Eden model. Means Eden model is very simple. From if we just focus on a seed point, then from means this seed point and its neighbors. Suppose it is a 4 neighborhood criteria. Means it depends on you. Means you are the god when you are actually simulating the whole thing. So it may be a 4 neighborhood criteria, or it may be 8 neighborhood criteria. Means if it is a box, this pixel is a box. So surrounding this pixel, you can actually find 8 boxes or 4 boxes. 4 boxes means in a perpendicular directions. So left, right, upwards, downwards, and in the angular direction, another 4 boxes. So if you just think about 4 neighborhood criteria in the perpendicular directions, then obviously that is referred as 4 neighborhood criteria. And with this, if you place the other vesicles in a random fashion, then again, suppose you have placed it at the right direction, then there will be 2 such vesicles, and then obviously the means particular neighborhood will be recreated again. So it will not be only 4 or 8; it will be more than that. So among these neighbors, again you just randomly choose a particular position and fill it up. So this is called Eden model. So Mole's labyrinth model is actually about emergence of these seeds, random emergence of these seeds within the system space, and then Eden model is giving us the idea of growth of these means clusters from starting from these seed points. So we thought that these 2 models will be very much appropriate for this type of case, to define this case, if we consider the system scale as the vesicle. So we have started like this. We have taken a kind of system space in this manner. So obviously it is digitally defined, means the boxes are there, pixel boxes are actually there. So it's called actually a kind of 2-dimensional lattice. So it is lattice simulation, or it may be referred as cellular automatons. Technically, these are the terminologies, but to understand it is very simple. It is a kind of system space. We have divided it into some discrete space. Obviously, we need to divide it into discrete space. We cannot actually think of a infinite number of points to describe the whole thing. So we are actually taking the help of discrete space, and in real life sort of scenario, we can do that. Once we can actually have a kind of idea what is going on within this discrete space, then obviously we can try our best to interpret the whole thing when it is not a kind of discrete, but it is a kind of analog or infinite possibility of many points. So that we can actually extrapolate from there. So object appears within this digital image in this manner, and because the pixels are of means of very small size, so obviously it appears to be a very continuous sort of. But if we just zoom it on, then obviously we'll find this type of formations, box formations. So it's like this. So see, in this lattice, which we are actually thinking as a system space. We can randomly place some points, and from these points, actually we follow the Mole's labyrinth model, and then we actually follow the Eden model to grow the clusters from each of these points. So it will appear like this. And finally, the beauty of this simulation can be actually visualized when we compare it with the actual formation of the aggregates at this system scale, because we have actually somehow reduced this system scale for the actual objects, actual aggregates. So A means the actual means formation we have actually derived by reducing the scale from the actual image, and B is the simulated image. And just imagine there is such a similarity between these two images. So visual sort of validation is already there. We can readily understand that the things are very much validated visually. Then obviously the task will be to actually again compare these two formations. One is actually has been formed through real life mechanism, and another is through simulation. So to compare it through the parameters, and then we found that it's so nicely corresponding this experimental values and simulated values. If you just go through that, you will find that it's a very good correspondence between these two. And another very good thing about this simulation is that we can actually find out the number of seeds and simulation steps also that is required to get this type of formations. So obviously simulation step is actually giving you the idea of the simulation time. So this way we are getting the idea of all these things, and the beauty we can understand if we just look at the last two columns. Then obviously we find that without spectrin the number of seed is very less, and actually number of seed is very less, and for that reason it can grow for many steps, many simulation steps, and it is 16. And for other cases where the spectrin is present, seed number is quite high and the number of simulation step is very less, and that is actually giving us the idea that there are many such formations of vesicles, small vesicles, and which are actually growing further, and obviously and giving rise to this span sort of assembly. And it is happening because of so many sort of hand-to-hand connections, and these hand-to-hand connections, who is giving these connections? So we have predicted that this spectrin is giving this type of connection. The spectrin is offering this type of connections, and that's why there is a kind of formation like this. These are the formations. So with this, we were actually tempted to actually think that whether whatever we are thinking, that it is actually a formation of the seed points, and from there we get the formation of the clusters like this. So we have actually tested on that, and we found that yes, if we just look at this first image, there's the image A. That is actually the single seed point you can think of, the formation of a vehicle like this. And if you just come at the last sort of image, that is the ith image, you will find that there is a formation of two such vesicles. From one, another vesicle has been grown or maybe assembled over there. So whatever we have thought theoretically, that has been validated also. And another beautiful thing we found that when actually we have tried to actually disrupt this type of aggregate structure by external force, actually hydrodynamic force, then the first slide that is giving us the idea of this, sorry, this one where actually the first one, image A, where the aggregates are separated to each other, we found that these aggregates without this spectrin, this absence of spectrin, it is actually not so rigid and it gets broken very easily, means with the application of some external force, whereas the B, C and D images, when we have applied this external force, again hydrodynamic force, same hydrodynamic force to break this formation of these aggregates, then we found that it is not so easy to break these aggregates. So obviously, spectrin is giving it is giving strength in the formation of this type of aggregates. And how it is giving this strength? Because of so many connections, hand-to-hand connections, the strength is there. So those things we have interpreted, and it has been published in a very good journal also, Journal of Structural Biology. That is a very quite good journal. So this type of thing we can do, and we can actually, for this purpose, we can have a kind of collaboration among us. So that is the thing I have tried my best to point out over here. And thanks to all of you. And if there is any question, I am open for that. So please, over to the organizer. Hello.
Hello. Yes, sir. Yes, sir. Yeah.
Yeah. So if there is any question,
yeah.
I'll be very much happy
Participants,
to discuss.
we are now open for questions. Hello, participants.
So if there is no question, then obviously you can give my email. I think that is there. So
yes, sir. We have
there may
created
not
a
be any
blog
instant
and
question.
everything has been posted there. Even your video lectures will be posted in the YouTube link.
Okay.
So everything is available to them, sir.
Okay, then obviously I will be very much open. I will welcome the questions afterwards also. There may not be any instant sort of question. It happens during a long discussion. So many things actually culminated within the mind. So obviously afterwards the questions obviously will be very much welcome for to me. Okay.
Okay, thank you, sir. 1 second, sir. Harshita will take over.
So it's my pleasure to conclude the session. The crucial role of data science to understand various activities and characteristics of biomolecules in relation to different pathophysiological conditions. The three types of methods of reasoning were discussed. Those are deductive mode of reasoning, inductive mode of reasoning, and abductive reasoning. And also, the role of spectrin to maintain integrity of RBC cell membrane was discussed, and also the four major branches of system engineering such as system study, system modeling, simulation and validation, system optimization, and decision making about the system were discussed. And also it was discussed about the to characterize the events in absence or presence of spectrin. So I wholeheartedly thank Dr. Tapobrata Lahari sir for such a valuable session. So it was a very knowledgeable session, sir. Thank you.
Thank you, sir. Sir, okay, thank you all participants. Please join us for the valedictory session at 2:30 p.m. We'll have a final quiz and feedback over there. Thank you all.